Hi, today we're going to be talking about the domain and range, and we'll also talk about piecewise defined functions. These notes are based on the free college algebra textbook from OpenStax, and the notes correspond to section 3.2 from this book. So if you want more information or definitions or details, you can go to the website that's listed at the bottom of the page. And that will be there throughout the presentation. So the first part we're going to talk about is the domain and range. So for the first four, we're going to find the domain of each function, and we're going to use interval notation to describe the domain. So if you watched the previous video, I talked about, or some of my previous videos, we've talked about interval notation before. So we're going to be looking at the domain. Here's the main thing you're looking for when you're finding the domain of a function such as these. You're really looking to see if there are going to be any restrictions on your domain. So remember, for something to be a function, your x values cannot repeat. So in the previous section, you memorized some toolkit functions. If I multiplied number 1 out, we would end up with an x cubed. This is a cubic equation or cubic function, and the graph looks something like that, and it is a function. There are no restrictions on the domain. The domain can go from negative infinity to infinity. For number 2, this is a square root function, and for this we are trying to just look at the principal or the positive square root. So for that reason, our graph looks like this. There are restrictions on the domain here, because remember that whatever is under the radical, in order for it to keep in the real number system, it has to be positive. We don't have negatives under the radical and stay in the real number system. So here we want to make sure that what's under the radical, which is the radicand, we want to make sure that that is always greater than or equal to 0. So it needs to be non-negative. So it's positive or 0, but not a negative. And in number 3 and 4, what we have to remember is when we have a fraction, the denominator, or the bottom of the fraction, cannot be equal to 0. Because remember that creates an undefined value. So we don't want it to be undefined, so the bottom or the denominator cannot be 0. If you don't have one of these cases, for most of your college algebra experience, you're going to see that these are the cases you're looking to kind of define your domain. If you don't have one of those cases, like in number 1, your domain is going to be all real numbers. It can be anything. It's not restricted in any way. So it can be any value. X can take on any value. So number 1, like we just said, the domain is unrestricted. It's from negative infinity to infinity, and I'm writing it in this way. There are other ways I could write it, but I'm writing it in this way because of the directions. It says use interval notation. So the domain is unrestricted. It goes from negative infinity to infinity. In number 2, we do have a restriction. The restriction is going to come from the radicand. So the part under the radical has to be greater than or equal to 0. So I'm simply going to take what's under the radical and say it has to be greater than or equal to 0, and then solve that inequality. So to solve the inequality, I'm going to add 2 to both sides. That gives me x must be greater than or equal to 2. And now from a previous section, I know how to write that in interval notation. This is going to be 2 or greater. So the domain, the D is going to stand for domain, is 2 with a bracket, because it can be 2, right, because of the or equal to sign, comma, infinity. So as long as it's 2 or bigger, that will be part of the domain of the function g of x. For number 3, since this is a fraction, our function h of x, we want to make sure that the denominator is not 0. So what I'm going to do is just say the denominator cannot be 0. And I'm going to solve this just like I would an equation. So minus 2, minus 2. So if the not equals 2 messes you up, that's fine. You can just use an equal sign. So let me do that. And then remember that these are the values that x cannot be. Okay? So 4x is equal to 2, or negative 2. And then you're going to divide by 4 to get the x by itself. And so then x is equal to negative 1/2. When you reduce the negative 2/4, you get negative 1/2. This is the value that will make the bottom 0. So x cannot be this value. So x can be everything except this value. So in order to use interval notation to leave out a value, you're going to say negative infinity to that value with the parentheses. Remember, the parentheses means everything up until that point, but not that point. So it can be everything up until the negative 1/2, but it doesn't include negative 1/2. Then you use a union. You put negative 1/2 again with the parentheses. Again, it does not include the negative 1/2, and then it goes to infinity with the parentheses. So this is the way you exclude one value. It includes everything except this negative 1/2, because that's the endpoint that's not included. And number 4 is going to be done the same way as number 3, but you can see here that instead of having a linear equation, we have a quadratic equation. So it just means it's going to be a little bit more work, and you're going to get 2 excluded values instead of just 1. So x squared minus 2x equals 15. X squared minus 2x minus 15 equals 0. We don't want it to be 0, so we're going to solve here to find the excluded values. So we're going to factor this, and we'll get x, what multiplies to get the negative 15 and adds to get a negative 2. Well, that'll be 5 and 3. And if we make the 5 negative and the 3 positive, that will multiply to give us a negative 15 and add to give negative 2, so that works. Remember, from the zero factor property, we can set each factor equal to 0 separately and then solve those linear equations. So now add 5 to both sides here. X equals 5. So that's one value we do not want x to be, because that would make the bottom 0. And you could check this by plugging it in for x, and you would see that you would get 0. And then the other one, we've got to subtract 3 from both sides. And so you get x equals negative 3. Remember that this is your other excluded value. So x can be anything except 5 and negative 3. So now we're going to write this in interval notation. So we're going to start at negative infinity, and we're going to go all the way until we have to use the negative 3 first, because negative 3 is smaller than 5. Your interval notation always has to go from smallest to largest value. So our first interval is negative infinity to negative 3. Again, we use the negative 3 first because it's the smallest. Then we're going to do a union. We're going to go from that smaller boundary to the larger boundary. And then we're going to do a union, the larger boundary to infinity. So notice what happens here is we are using the union, and the excluded points that we're using are hugging the U, right? They're hugging the union. And they have to be in order from least to greatest. So negative 3 hugs that union because that is our first boundary. And 5 is going to hug the second union because that is our second boundary. And so what this does is it includes every number except those values. And the key here is that you used parentheses here because that excludes the endpoints, right? If you had used a bracket, then that would defeat the whole purpose. That would be including that endpoint. So there's your domain. So those are the main things you need to look out for when you're finding the domain of these functions. You're looking for square roots and fractions. Otherwise, in general, your domain is going to be unrestricted, which means negative infinity to infinity. So for 3.2, we're going to use these graphs now to write the domain and the range of each function using interval notation. So here, the previous examples, we just did the domain, which is the x values, right? So x values. Remember, the range is the set of y values. So here we wanted to find both of them. So for the domain, we're simply looking at the x, how far left and how far right it goes. So the x values, remember, are on the horizontal axis. So we're simply looking for how far left it goes and how far right it goes. So the x, the farthest left it goes is 4, and the farthest right it goes is 8. So for our domain, we're going to go from 4 to 8. I was trying to write an infinity. Let's try that again. 4 to 8. Okay, now you have to remember if you need to use a bracket or parentheses. So remember, the closed circle is the same as a bracket, so we're going to use a bracket. And the open circle means that point is not included, so we're going to use a parentheses. All right, and now for the range. So I'm going to do the domains in red and the range in blue. So for the range, remember the range is the y value, so that is bottom to top. So we're going to see how low does it go and how high does it go. So the bottom of the graph is here, so that's 2, and the top of the graph is 8. So our range is going to go from 2 to 8. The 2 is associated with an open circle, so that's going to be parentheses, and the top 8 is associated with a closed circle, so that's going to be a bracket. Okay, so now let's look at number 6. First, we want to look at the domain, so that's the x value. So the domain is here. So the farthest left the graph goes is 2, and the farthest right it goes is 6. So the domain is 2 to 6, and I used brackets both times because I had closed circles both times. The range is bottom to top, and remember, I'm not, what in the world? Okay, now I just realized this graph is missing the negatives. So if your 0 is up here, right, and the numbers are going, as you go down, they get bigger, that doesn't make sense. So these should be negatives. Okay? Now that makes more sense. So your range is always bottom to top, and that's because you're using the smallest number first in your interval notation. That's very important. When you're doing interval notation, if you write it in the wrong order, it will be incorrect. So your bottom is -6, and the top is -2. So -6 to -2. There's not a closed circle or open circle at the bottom, but we're going to assume that it reaches that line of -6. So we're going to use a bracket. You're always going to assume that it touches that point, because unless they have an open circle, you just have to assume that. And then -2 is the top. It does have a closed circle, so you know for sure that that should be a bracket. All right, let's look at the next one. So same thing, we're going to find the domain and range. So the domain is going to be in red, and the range will be in blue. I'm going to go ahead and write that down so I can remind myself. All right, so the domain, left to right. So the farthest left point of the graph is here. So that's associated with an x value of -3. It is a closed circle, so bracket -3, comma. The farthest right it gets is here, so that's associated with a 2. And it's an open circle, so it'll be a parentheses. Okay. Now, range is bottom to top. And I keep saying this because it's going to be easy to get confused when you're doing this. You're going to start forgetting, should I look to the left or the bottom, or where does it go? So always remember, domain is left to right. Range is bottom to top. And if you remember it that way, it's going to be a little bit easier as these graphs get more complicated. So range, I'm looking for my bottommost value. Well, that's down here. That's associated with a -5. Again, that's a closed circle, so it's a bracket. And then it goes all the way up to here. This is the highest point, right, on this graph. So that's associated with a y value of 4. There is no open or closed circle. I just made one. But if you look, it's just hitting that 4. So we're going to assume that it is a bracket. All right, let's look at number 8. So the domain. This one is a little bit tricky. What you have to look at here is there are 2 separate pieces that are not connected in this graph. Notice this red dotted line in the middle. That's an asymptote. The graph never crosses that line. So there's also one here. The x-axis is acting as one. And so you have to keep that in mind when you're doing this. There's 2 separate pieces. Just like when you use the number line and you have 2 separate pieces on the number line, you have to use a union. You're going to do the same thing here. So you want to start with the leftmost point. Your leftmost point is right here. So it goes to the -6 on the x-axis. It's a closed circle, so it's going to be -6 with a bracket. That line, or that piece, goes all the way until this point, which is given by this ordered pair, and the x value is -1/6. So you're going to put -1/6. It was a closed circle, so it gets a bracket. Okay, if you did not have this ordered pair, you would just have to guess where this was on the x-axis. So you might guess 1/3, or -1/3, I should say, which is probably what I would have guessed. I would have guessed -1/3. If you guess something pretty close, that's usually going to be fine, unless it's given in this case. It gives you the x and the y values. So you're going to look at the ordered pairs so you know what to use. Remember, the domain, you're only interested in the x value. So you don't care what the y value is, you're only looking for x. Okay, now, don't make the mistake of the domain. Some people would say, oh, the leftmost value is -6, the rightmost value is 6, and they would say it's -6 to 6. But that's wrong, because they are including all this part in the middle. Let me highlight it. They're including all this part in the middle that has no line on it. So that would be wrong. So you don't want to do that. So you have to make sure that you're looking at the different pieces separately. Okay? It's really important. So we got the first piece, -6 to -1/6, union. Now the next piece, it's here, and the x value is 1/6, so it's going to be bracket 1/6, comma, and then it goes to here, which is 6, bracket. Okay, the range is going to be extremely similar. So let me erase all these red marks on the graph, and then we'll look at the range. Okay, so the range, we're looking bottom to top. So the bottommost value is here, so that's a -6 with a bracket. And you don't go all the way up to the topmost value yet. Remember, you have 2 separate pieces. So this first piece goes until here, and the y value associated with that is -1/6. Union, the next piece starts at +1/6, and it goes all the way up until 6. The domain and range happen to be the same because they use the same type of points. That's not always going to be the case, but it is this time. So you just need to look at your points and see if that's the case or not. Okay, number 9. We have another graph. We want to find the domain and range. So the domain is going to be our set of x values, and our range is going to be the set of y values. The domain is left to right. So our leftmost point is here. That's associated with the -3, and it is a closed circle, so it's a bracket -3. Notice we only have one continuous graph here. There are not pieces to the graph. So we're going to just go from -3, and then the rightmost value is over here on the graph, but look, there's an arrow at the end. The arrow means it continues forever. So it's going to continue to go up, and it's going to continue to go to the right. So domain is left to right, so it's going to continue to go to the right, so that'll be an infinity with a parentheses. Range, bottom to top. So the bottommost value, a lot of people are going to make a mistake and put -3, but that's incorrect. Remember, you're looking at the y value. Your y value is 0. So the bottommost value is 0. And then the topmost value is up here, but again, it has an arrow, so it's going up forever, so infinity. So don't make the mistake of putting the -3 as your y value, because it's an x value. If it helps you, you might want to label the point. The point is -3, 0. That shows that your x value is -3, which is why the -3 is used in the domain, and the y value is 0, which is why 0 is used for the range. All right. So the next part of this section deals with piecewise defined functions. So we're given a piecewise defined function, and then we're going to be asked to write the domain and range in interval notation. And a lot of times it helps to sketch the graph in order to define the domain and range. I would highly encourage you to do that. You don't have to, and we can talk about that in a minute, but that's usually kind of how you want to look at it. So let's go ahead and try to graph this first of all. So a piecewise defined function means this graph is going to be defined two different ways depending on where your x value lies as far as this boundary goes. So let's look here. We've got if x is less than -2, it follows the pattern of x plus 1. If x is greater than or equal to -2, it's going to follow the pattern of -2x minus 3. So -2 is kind of a boundary. It separates how this graph acts. So I'm going to go ahead and draw this boundary line that crosses through the x-axis at -2. So this lime green line is going to be a boundary. It's going to separate my graph in half. On the left side, so when x is less than -2, that's going to be on the left side. I'm going to use red for that graph. Okay, and so that side is going to be defined by y equals x plus 1. And on the right-hand side, when x is greater than or equal to -2, it's going to be defined by this function. So it's going to be defined by y equals -2x, not plus, minus 3. Okay, so now we have them separated. What's in red should look familiar. That's simply a linear equation. It's going to be a line. Same for the blue. The blue is a linear equation. So all you're going to do is graph each linear equation on its respective side so you can see what's happening. So remember that the slope is in front of the x. So there is no number in front of the x, so it's assumed to be 1. And the constant here is the y-intercept. So the y-intercept is 0, 1. So I'm going to graph this. Right now I'm going to ignore the green line. I'm going to graph it like I would any other line. So 0, 1 is my y-intercept. And then I'm going to use my slope. Slope is 1, so it's rise over run. So up 1, right 1. Or down 1, left 1. That's my slope. Because remember, two negatives make a positive. So if I go down and left, that's a negative and a negative, which makes a positive. Okay, so I'm just going to continue to draw these dots. Okay, because it's a line. So I just follow the same pattern. Okay, so if I graphed this and connected all the red dots, I would see that I would have this line. And if I just had the red equation, if I just had the red equation, that would be it. But This is only true if x is less than negative 2. So it's only true on this part of the graph. So I need to get rid of all the right-hand side red. So all this, well, let's see if I can get, needs to be gone because it's not true for that side of the equation. So that's what happens when you have a piecewise defined graph, is that it only works on certain pieces or sides of the graph. So the next thing I need to look at is the fact that this was a less than sign right here, no equal to sign. So that means I need to have an open circle here for my red, not a closed circle. Okay, so that takes care of the first part. Now we're going to do the same thing for the blue. So I'm going to go to my y-intercept. So my y-intercept is 0, negative 3. So 0, negative 3 is here. And now I want to use my slope, which is negative 2, or negative 2 over 1. So I'm going to go down to right 1, down to right 1. Okay, and or I could have gone up to left 1. You have to have one negative. So negative 2, 1, or 2 over negative 1, both give you negative 2. Okay, up to left 1. Now the line, or the dot on the green line, since there's an or equal to sign, will be a solid circle. And then I'm just going to connect those dots. And remember that this only is good on the right side of the green line. And so that is my piecewise defined function. The red happens on the left side of the green line, and the blue happens on the right-hand side of the green line. Okay, so now that we have our graph drawn, we want to give the domain and the range. So the domain is going to be your x, or left to right. So we have two pieces. The red goes from negative infinity to negative 2, not including negative 2, but the blue does include negative 2 and goes to infinity. So overall here, your domain is negative infinity to infinity. Even though there are two pieces, there's no gap. So while negative 2 is not included in the red, it is included in the blue. So there is no missing x value. All the x values are defined at some point on the graph. So domain is negative infinity to infinity. Your range is bottom to top. So let's just look at the blue line because it goes higher. So it goes down to negative infinity, and then it goes all the way up to 1. So 1 closed bracket is going to be my range. All right. Let's look at another example. Okay, so for this one, first I want to draw my boundary line. You get that from these inequalities. So they're both compared to 0. So I'm going to have one boundary line right at the 0. And so now I want to write what goes on each side. So x is less than 0 is the top. So that's going to be on the left. So that's y equals x squared. And x is greater than 0 is on the bottom. So that's going to go to the right. And that's going to be y equals 1 minus x. So y equals 1 minus x. I can rewrite that as negative x plus 1. It's the same thing, right? This goes here, this goes here. And I did that because now that's in y equals mx plus b form. And that's easy for me to interpret the slope and the y-intercept. So that's why I rewrote it like that. Okay. So let's start on the left. Y equals x squared. So if you have this memorized, you know that the y equals x squared is a parabola. Okay, and you can just pick points to verify that. Notice that neither of these inequalities have an equal to sign under it. So they're both going to be an open circle. So if I picked x to be 0, so one way you could do this is do an xy chart. If I picked x to be 0, 0 squared is 0, so y would be 0 as well. So open circle here on the green line. And then I'm just going to continue to pick x values to the left of the green line. So -1, -1 squared is 1, so this would be a point. -2 I could pick for x. -2 squared is 4. -3 squared is 9. And then I would be off the graph. So I'm just going to pick those points there. So we're only going to get half of a parabola since it's only on half of the graph, right? So there's the red. Now the blue, this is going to be a linear equation. So my y-intercept is 1. So it's going to be at 0, 1, open circle again. And then my slope is -1. So I can go up and left or down and right. The up and left is not going to be helpful because that's going to take me onto the wrong side. So for the -1 slope, I want to go down and right because that's going to take me to the correct side of the green line. So if I continue in that pattern, and you can pretend like that's a straight line, that's going to be the right-hand side, or when x is greater than 0. So now that we have a sketch of the graph, we're going to write the domain and range. So again, the whole point of these piecewise defined functions is that different things are happening on different parts of the graph. And the key is to kind of draw your boundary line in green or some color, and then just graph it like normal on each side. So the domain, we want to look and see if there's any missing pieces. So they both sides go all the way to the 0. But neither side includes the 0. So 0 is completely excluded from this graph. So we'll have -infinity to 0 with a parentheses, union 0 to infinity. So we're leaving out the 0. Everything else is included, but not 0. And then the range is bottom to top. And so all of the y values are included somewhere on the graph. So the blue goes up to 1. It goes from -infinity to 1, and that overlaps with the range of the red, which is 0 to infinity. So the range is going to be -infinity to infinity because it goes all the way down and all the way up with no gaps on the y-axis. All right, so let's look at the next one. So number 12. So here we have 2x minus 3 if x is less than -1, and square root of x if x is greater than 4. So notice our boundary points here are different, right? We have a -1 and we have a 4. So I'm going to go ahead and draw 2 green lines. Okay. So if x is less than -1, that's going to be to the left of the first green line. So that's going to be y equals 2x minus 3. That's a linear equation. And then x is greater than 4 is going to be to the right of the second green line. So y equals the square root of x. That means nothing is happening in this middle section. So this is completely off limits, right? There's nothing here. So there's a gap. Okay, I don't want you to think that the green is like part of the graph. I'm trying to color it out. So there's this big gap here where nothing is happening. Nothing here. Okay, that's not some crazy squiggle part of the graph. So nothing is there. So let's look and see what we're going to have on each side. So 2x minus 3, remember we need to start with the y-intercept, so that's -3, it goes here. Remember we're going to have to erase that, but I've got to do it for graphing purposes. Now my slope is 2, so it means I can go up to right 1, which is not going to be helpful, it's not the right direction. Or I can go down to left 1, because that is going to take me in the right direction. 2 negatives make a positive. I want to open circle here because my inequality symbol does not have an or equal to sign. It's a strict inequality. I'm going to continue to go down to left 1, and I'm going to connect those. And then I need to erase this little red dot that I used to start my graph. So erase that. Okay, and so now let's look at the right-hand side of the graph. So y equals the square root of x. So I can use different points. I want to start with a 4. If I choose 4 for x, the square root of 4 is 2. So here will be my first point, right? So if I choose x to be 4 and I plug that in, the square root of 4 is 2. So that's my ordered pair. The next one I want to choose probably is the 9 because that's the next perfect square. So if I choose 9, the square root of 9 is 3. So that will be my next point. And if you memorized your toolkit functions, you should remember that the graph looks like this. It's like half a parabola on its side. And so this is going to look like that. All right, so now we have a sketch of the graph. So the domain and the range. The domain, you can see that the big green squiggle, that's all left out. So we're going to have a big chunk that's left out. So the red goes from negative infinity all the way to -1. Oops, -1. And -1 is not included. It's an open circle, so I need a parentheses. Union, the blue starts at 4. It's a parentheses because it was an open circle, and it goes forever to the right, so it's infinity. The range, hopefully you can see that there's a big gap between here and here where there's nothing happening here either for the y. So there's a big gap in the range as well. So for the red, the range is going to go from negative infinity all the way up until -5 with a parentheses. And then there's nothing until you get to 2. So union 2 to infinity. It has an arrow on it. It's going to continue to go up forever. Okay. So hopefully that helped you with the piecewise defined functions. If not, look on Khan Academy. There are some other good examples there as well. Okay, the last part is evaluating for given values. So here the key is, these are actually very easy if you remember to plug it in the correct spot. So if I'm looking at the first one, I have f of -3. The key is to looking up here and seeing which one it goes with. It either has to be less than -2 or it has to be greater than or equal to -2. So the key is figuring out which one it corresponds to. So let me do it this way. Let's do red and blue. So I'm going to erase this one. So we're going to have to figure out if the number given goes in the first part or the second part. So -3, is -3 less than -2 or is -3 greater than or equal to -2? -3 is less than -2. So -3, I'm going to use the red equation for this one. Okay. For part B, -2. -2 is greater than or equal to -2. So it's going to correspond to the second equation. Okay. -1 is also greater than -2. So that's going to correspond to the second equation. And 0 is also greater than -2. So that's going to correspond to the second equation. So the first thing you want to do is look at your value. So look at your value. Here I have -3. And look at the two if statements and determine where it goes, which one is true. Then use that one to plug it in. So since the first one, -3 is less than -2, I'm going to plug it in the x plus 1. So this is going to be -3 plus 1, which is -2. And that's it. That's my answer. So the key here is just making sure you plug it in the correct one. For the second one, -2 is equal to -2, so that corresponds to the blue. So I'm going to plug it in for -2 times -2 minus 3. So that's going to be +4 minus 3, which is 1. And that's it. Okay, for part C, -1 is greater than -2. So again, I'm going to plug it into the second, or the blue. So -2 times -1 minus 3. That's +2 minus 3, which is -1. And for part D, 0 is greater than -2. So I'm going to plug 0 in for the blue. So -2 times 0 minus 3 would be 0 minus 3, which is -3. Okay. Same thing for number 14. This just has 3 pieces, but it's the same thing. So I'm going to do the first one in red, the second one in blue, and the third one in green. And then I'm going to determine which one goes where. So for part A, I'm looking for -1. -1 is less than 0, so that's going to be the red. For part B, 0 is equal to 0. Look at the blue. That has a 0 is less than or equal to x. Not the red, because there's no equal to sign. So since the blue has the or equal to sign with a 0, I'm going to use the blue. For part C, 2 is between 0 and 3, so it's going to be blue. And for part D, 4 is greater than 3, so that's going to correspond to the green. And now you just need to go in and fill in the information. So for part A, it's red, so I'm going to use 5x. So I'm going to have 5 times -1, which is -5. For part B, I have 0, and we're going to use the blue. Notice that there's no variable there, so the answer is just 3. For part C, for 2, it's going to be 3. So really, that's easiest. If there's no variable, you just use the number given. And then for part D, we said 4 is greater than 3, so we're using the green. So that's going to be x squared, so 4 squared, which is 16. And that's it for this section.